Even though our official topic in plan uh, should stop after discuss the single continuous predictor model, but I just like to give you a light introduction on what is different when you have a multiple predictors. Um, so I'm just going to discuss that briefly here in those slides. So I'm just telling it as continue to improve the model. Okay, continue to improve the model. A person's wage could be determined by many different factors. You understand that? Industry, gender, education, the region, right? Number of years working for the company, things like that. So education could be used for predictor, but even with the same level of education, other characteristics such as a person's gender, experience can have influence over the determination of the wage. So next, I attempt to improve the model by adding these predictors that are available from the provided dataset. To improve, the improvement will be made visible through two areas. Your residual plot should be improved, and your R-square score should be improved. So here, I'm looking at the gender effect here, okay? This is a gender effect. I think blue is for the male, red is for female. So if I plot those in a different color, as you can see that the slope may be different for the male group and the female group. Okay, so it means that men with a higher level of education, they may make more money than women. Okay, the slope may be different. I'm not sure. We'll have to confirm it. So let's say it is possible that female and male have different slope. They may have same intercept, but they may have a different slope. I don't know, but we have to find it out. Okay, so if that is one difference which is significant, we can also build that into our prediction model such that we can make it is your education. We can also make it as a gender. Okay, so let's see if we can, this type of model can improve our previous finding. Or you can even add some more other predictors to continuously improve our predictions. So here, it does look like we actually have a different slope for the female and male. So what does it mean by they have different slope? I'm telling you what, men will make more money given the same level of education. Okay, men will make more money given the same level of education than female have. Okay, so that is what it is when I say they have a different slope. Okay, so if you want to compare like this, okay, compare like this and see, this is 18 year, and this is 18 year, this is 18 year. So what this model telling you is that men in fact make more money than female given the same number of year of education. So this model here is 40 plus 45. Let me just use x1 here, okay, as education, and minus 1.1985, which is the gender. So here, this is going to be the binary predictor here in this case, okay, and then negative 0, 8, 6, x1 multiply x2. Okay, so this is a term which makes men and women, or male and female, have different slope. So let's find it out. Let's say 0 is going to be the male, right? 1 is female. Okay, so in that case, you will see that let me write down the equation for the male here first. when you predict the male group, you're going to be using, no, this is B0. Okay? No, let me just write it in full so that you can tell what it is. Okay? And no, the first one is education. What I'm doing here, I'm sorry, I'm kind of distracted now. Maybe it's because the last session. But this one here is male, therefore you're reporting 0. Okay? This one also contains 0, therefore this is another 0 here. So this is basically the model for males. Okay? And if you think about that, the model for female is going to be the same intercept for 0 plus x1, okay? And female, you have negative 1.1985, okay? Multiplied by 1, and then you also subtract a6 multiplied by 1 multiplied by x1. Okay, so these two can be grouped together for 0 and plus 45 minus 0.084 multiplied x1, which is education. So you see the slope is different here. Men slope is slightly higher than women. Okay, so this is one way to improve the predictive accuracy of your model by adding additional predictors. So in fact, I added a bunch more predictors here to improve the model. As you can see, I added female. I also added experience. Okay, I also this is the interaction between female and male, and this is interaction between female and experience. So these are the concerns. These can tell us between what is different between men and women. Okay, not only with more education, women makes less money. With the same level of education, women makes slightly less money. With the same level of experience, female also makes less money than female. That is what we were able to discover using our data set. So R square has actually doubled than just using one variable here. We have used 1, 2, 3, and these two are called something called interaction term. So interaction terms like this allows us to let your predictor have different slope when you're dealing with the multiple groups. Okay, so you may have noticed that these values have changed, right? In one case, education is 0.541. In another case, when you added more predictors here, the education becomes much bigger. The effect of education becomes much bigger. That is because it's very complicated to explain, but in a nutshell is that by adding more predictors to the model, when you estimate it, you have to estimate all these beta 1. You have to estimate all these things together at the same time. So in order to make this crystal clear, you need to learn the matrix algebra to understand why adding more predictors change the size of the coefficients. Okay, usually direction does not change, but usually size changes. Okay, so it means that if you add more predictors to this model, you will also likely see that these numbers change again. These also will also change. Okay, so that is something I can say. But at least in this case, education in both cases are a significant predictor. So we call those type of predictor as a consistent predictor or stable predictor. They don't change its statistical significance as you add more predictors. In some cases, you can see that if you add more predictors, the statistical significance disappears. Okay, but some of them, especially if those predictors are very strong predictor, their statistical significance does not go away as you add more predictors. So here, this is a residual plot. I'd like to show you whether they have changed or not. So here, it has improved a little bit. This is average, okay? This is average. At least in this area, it's more like a randomness, although you have a lot of overestimation here. Why do I call it as overestimation? It's because these, okay? Don't forget the residual basically means the difference between y and the predicted value of y hat. So when your predictor is too small, that becomes underestimating. When your predictor have a too big, that becomes overestimating. Okay, so here this part looks much more normal than the previous case, right? If you look at the previous residual plot, okay, here this part is much more dense and much more spread than above. There is still concern, but I think it's much better than the previous one. You need to continue to add more predictors that can explain the relationship between education and wages, hourly wages. This is experience. We also need to compare experience because we added a new predictor here as experience. In this case, this is much better, but you still have a lot of underestimation and overestimation here and here, okay, that need to be explained. You cannot fix the residual plot perfectly, but you need to know the bottom line is, okay? So here, when you start to have more than when you start to have more than 2 variables predictors, it is very difficult to visualize, okay? Like binary predictor and categorical predictor, it's pretty simple to visualize those things in terms of their relationship with x and y. However, when you have a multiple x's and the relationship between y is very difficult to visualize, to make it into pretty plot. So for example, in this case, I had to visualize the relationship between education, experience, and wage at the same time together. As you can see, I have to use 3-dimensional plot to visualize their relationship. I was able to add one more additional variable so that it became a 4-dimensional, but that is because the last predictor is somewhat binary. So as you can see that from this plot, the layer on the top is the male layer. The layer on the bottom is the female layer. So the fundamental insight from this plot is that given the same amount of education and experience, in general, female makes less money than the male. That is something really powerful that you can deliver from this model. Okay, so yeah, I probably have heard about the glass ceiling. The glass ceiling is something unfortunate. There's a ceiling that is invisible, that clearly exists. So glass ceiling has been visualized using this package, using this data, right? So female, there's a certain layer for female, and that makes clear, distinction between the male and female in terms of how much money they make. So this is our multivariate model we have so far, where you have multiple predictors, and I'm going to show you how to interpret the result. Okay, so this is our model, and when you interpret the result, you typically interpret one variable change at a time. Okay, so in other words, given all other variables remain the same value, change in this particular variable will accompany this amount of change in wage. So specifically, when female is equal to 1, okay, when the experience is equal to 3, okay, when these two variables takes these two values, and there's someone with education of 30, there's no 32 years of education, 18-year education, with someone with a 2 years of education. Given interpretation, it goes like this. Given other variables remain the same, with a 1 year increase in education, okay, there accompanies $7.25 difference in terms of how much they make in an hour. Okay, so again, that applies the same. Given the same amount of education two people have, right? Education is, both they have 10 years of education, and both of them are male. In that case, one person have experience of 10 years, the other person has experience of 20 years, right? In that case, the difference in terms of amount of wage they make each hour will be 7.25, because the difference between these two guys are 10, right? And you multiply the coefficient, and this is amount of difference in terms of how much they make each hour, given other conditions remaining the same. Okay, so when you have multiple predictors, this is the way you interpret your model. Given other predictors remaining the same, okay, that is a standard phrase you have to always add. Given the same gender, given the same level of experience, 1 year of increase in education will increase this much money, which is the size of beta 1. Okay? Given the same year of education and given the same year of experience, okay, change gender from male to female will increase the wage by this. Okay? But this is not actually meaningful, because you have to consider these interaction terms at the same time. Okay? So I will demonstrate a little bit more with the Excel demonstration as to how to specifically explain the result. Okay, so here, is the modeling process finished for the question? No. Can we trust the current coefficients? Somewhat we can trust it. We cannot totally trust it. We can trust the current result somewhat. Is the current model useful? It's useful in certain sense. Okay, what should we do next? Continue to reflect on the phenomenon and identify useful predictors. You kind of have to keep thinking about what are some other predictors that may have influence over the hourly income. You kind of have to keep think as someone who's trying to model the phenomena. Okay, and that means in some senses you're kind of acknowledging that there is a limited usefulness with the model you have so far. And number two is evaluate the data to add more predictors. You kind of look at the current data set. Is there anything that is more useful I can add based on your reflection? If your data does not contains the specific predictor you're thinking of, you may want to go out and gather more data to add more results, to improve your results better by adding more predictors. Okay. In conclusion, the workshop provided several mini sections that introduce the fundamental of the modeling in economics and business. Specifically, it produces what is known as a simple linear regression model. Here is the true identity of the model we've been learning so far. It is called a simple linear regression model. Okay, we reviewed univariate and bivariate models. While these models offer good and simple insights, we typically need more than one predictor to make more useful predictions. When there is more than one predictor in the model, the technicality of dealing with the data and the model becomes more complicated. And business and economics activities are very sophisticated. Building a good model requires many efforts. Yet the good results are not guaranteed, right? That is kind of sad reality, but that's also something that makes modeling very fun. Okay, there's something doable, but there's a certain level of challenge there. Someone famously said, all models are wrong, but some models are useful. Okay, it emphasizes the role of models as the insight provision tools and importance of being mindful in interpreting applying the model results in the real life. In some senses, you need to know that there's a limitation that what model can do, right? You kind of have to humbly acknowledge and there's a limit to the modeling. And then you also have to be careful as you try to apply the model and also interpreting the model because you understand the limitation of the model. Okay, I wish this workshop can give you some, something that is interesting, something that kind of ignite your interests in this direction. There are more to learn, and I'm providing the reference here. Okay, so see if these are available from the bookstores. A lot of them, I know that's been already translated. This is translated. This has been translated. I'm not sure about this. Okay, but there are more materials that you can use. So if you're not sure whether that certain book can help you or not, just send me an email or send me a message. We can discuss together so I can help you continue to learn this thing, okay? Okay, I hope you enjoyed it. I'm going to give you another assignment today. That'll be it. See you when I see you. Bye.